In this video we will see about the electrode potential. What is electrode potential? So what is electrode potential? So when a metal or you can take non-metals, sometimes non-metals also worked as a potential electrodes is dipped in a solution of its own ions. The following processes are taking place. So what is the mean? If you take the one beaker and you are in this electrochemical cell, you are taking two beakers, and here one is the rod, some copper rod. This is the or you can take the zinc rod here, this side, and there is a salt bridge between the ABC structure. If you see the ABC structure, here is the anode, and here is the cathode, and here it is B. So here another rod you took, that is copper, and that was the immersed or dipped in a solution that is also the same ion containing solution. Here if I add zinc sulfate solution, and here if I add copper sulfate solution, so then following process will occur. We'll see what are the processes will occurring. What will happen? Some metal you can take metal is going to be oxidized. Oxidation takes place, and this is going to be N plus electrons. Then you can the process of here the process of converting metal atoms into their ions is known as de-electronation process. That is we know de-electronation. This is we know as de-electronation process. So this is the process which is metal is converting into their respective ions. So or we can say this is named as solution pressure, or it is a solution pressure. So this is volt term, and here it is new term. So new term you are using in electrochemical cell, that is de-electronation process. So de-electronation process, or we can say solution pressure. Another thing is happen, that is metal N plus electrons. It is gaining N electrons, and it is converting into metal. So it is converting into metals. So the process of converting the metal ions into their atoms is known as just to remove this D, and this we call it as electronation process, or we can say osmotic pressure. That is old term. This is a new term, that is electronation. So here if you say the case 1, if you see case 1, if solution pressure is greater than solution pressure is greater than osmotic pressure, osmotic pressure, the net reaction will be metal is going to be metal N plus electrons. This is oxidation will takes place. So oxidation will takes place. Due to this reaction, electrode is negative charged. So as already told you, due to this one due to this effect or this reaction, due to this reaction, electrode is having negative sign, negative charge. Electrode is having negative charge, and solution is having positive charge. So therefore an electric double layer is formed between. So here an electric double layer formed and some potential is developed. So some potential is developed at the junction. So this developed potential is called oxidation potential, or we can say oxidation potential. Oxidation potential is represented with E ox or E m by m n plus. This is the oxidation potential. So what is the meaning of that? If you took the two beakers, as previously I told, so you can take these two beakers. In that immersing two electrodes. This is a bridge between the two beakers, that is a salt bridge, and here is the electrode. This is the electrode. If I assume this is zinc rod, this is the zinc rod dipped in a solution of zinc sulfate. So zinc sulfate, 1 molar zinc sulfate. What happened here is it is connected to some battery, and here you are taking another rod, and here you are dipped that the copper rod, and here it is you are taking 1 molar copper sulfate solution. So here what will happen? Here metal, this is the metal, right? This is metal. It contains some atoms. So metal is going to be so zinc is there. This rod is dipped into the solution, so this loses the electrons into the solution, and it is converting into zinc 2 plus and 2 electrons. That means there is a zinc 2 plus ions present in this solution. So obviously here there is a sign. If you take the sign here in solution, that is a positive sign outside, and loses this electrons. Electrons are containing negative sign here, so electrons are containing negative sign here. So this is the there is a charge separation between the charge separation is formed between the rod and solution. So this is negatively charged and this is positively charged. So this is some potential is generated due to the presence of the negative and positive charge. So this potential we call it as oxidation potential, or this is a E ox and E oxidation potential. If you take come this side, if you come to this side, this is electrons flow in this direction and electrons flow in this direction. And here what will happen, this whatever the electrons are there, here also the negative charge is generated. So negative charge is generated here, and this and in solution contains a lot of copper 2 plus ions, copper 2 plus ions. So here positive sign in this solution. So positive and negative sign, this is a there is a electrode potential is generated. That potential we will call it as here. Here the metal going to be copper 2 plus 2 electrons going to be copper. So here we can say it is a E red potential, or E of copper 2 plus 2 copper. If I am writing like this copper 2 plus 2 copper, that means I am adding 2 electrons here. If I am writing here like this, means here I am losing 2 electrons. I am losing 2 electrons here. This is the oxidation and this is the reduction. So this is the oxidation, this is reduction. So I can represent with the reduction. This is the electrode potentials, electrode potential. So here it is having some negative sign here, and here this one is having some positive sign, because here accommodation of the positive sign will take place. So this will give the positive sign due to this is the electrode potential. So if you say case 2, if you see case 2, if solution pressure that is E ox pressure is equals to osmotic pressure. So this is the osmotic pressure, then no net reaction will take place. No net reactions. In this case, electrode called, this is a null electrode. So this is null electrode, and here it is very very important point. If you note down, this is the note for a particular electrode, at particular concentration, and temperature, oxidation and reduction potentials, reduction potentials are having reduction potentials are having equal magnitude, but opposite sign. So opposite sign, if it is having equal potential, it's okay. E ox is equals to E red, but the sign will be minus here. So ox is equals to, oxidation is equals to reduction, but it is a minus sign. Why it is minus sign? If you took here the electrons are losing here, and here electrons are gaining, but it is an different sign. So here metal is going to be Mn N plus, and here E of metal N plus is going to be metal. That means here electrons are losing. That means 2 electrons or N electrons are losing here. Electrons are gaining. So electron plus N electrons are gaining. That means if you see, this is this is clockwise, this is anti-clockwise. If you see, this is the minus sign, it will come. So this is the relationship between the E oxidation and E reduction. So what is this is about the potential, how the potential is generated along the electrode. We saw here we see standard potential. What is standard electrode potential? So first we saw that the electrode potential, how the electrode potential is generated. Electrode potential generated due to the presence of this rod is containing some positive sign, and here electrons are containing negative sign. this is rod is this is the electrons, and rod is containing electrons, and here positive sign. There is a potential difference is generated between the positive and negative solution, and solution pressure and osmotic pressure. So here the electrode potential is generated. What is this standard electrode potential? What is the standard electrode potential? An electrode potential measured at 25 degrees of centigrade temperature and 1 molar concentrated solution concentration of an electrolyte solution is called standard electrode potential. In case of gases, electrode is 1 atmospheric pressure. That means room temperature and room atmospheric pressure is taken as standard. So standard oxidation potential is represented with, so standard oxidation potential is represented as E naught. It is naught means standard oxidation potential. Or what is oxidation? So metal is going to be metal ions, so E of naught. This is the standard oxidation potential. So standard reduction potential, I am writing here SOP, standard reduction potential. So standard reduction potential. So standard reduction potential we can write as SRP. So that is E naught. What is happening here? Reduction, that means metal, some ion will be there and it is going to be metal, that means gaining of electrons. So gaining of electrons will take place, it is converting into metal, or we can write as E naught of red means reduction. So if you take some of the metals and their standard reduction potential are given here. So standard reduction potential of E naught of zinc to zinc 2 plus. So what is this one, oxidation or reduction? Can you tell me? Oxidation is it oxidation or reduction? This is the oxidation, plus 0.76 volt. This is not your home appliance voltage, that is 240 270, that is not happen here. This is a small amount of voltage is generated due to the potential difference that we calculated in volts. So this is the oxidation is taking place, that means here losing 2 electrons and converting into zinc 2 plus. So E naught of zinc 2 plus by zinc, that means this is the reduction, right? So here what will happening, I am adding the electrons to the 2 electrons. If I add here, then this is going to be zinc. So this is the minus sign, 0.76 volt. This is minus 0.76 volts. If you see the copper, that is copper containing 2 plus is minus 0.34 volt. So this is the standard reduction potential of the. So here if you see the copper is going to be copper 2 plus, that is minus 0.34 volt, and here copper 2 plus is going to be copper, that is plus 0.4 volt. So next we will find out what is the EMF of the cell. So what is EMF of electromotive force? of a cell. So of a cell. So if you take here at constant conditions, that is inert cell. So at constant or standard conditions, so when we are saying that is standard conditions, that means we place some not. Don't forget this one. If you find anything anywhere not, that is standard conditions at 1 molar per concentration of the solution, room temperature and room pressure. So when electrons are not present, when electrons are not present in the net reaction, when electrons are not present in the net reaction, or electrodes of difference are electrodes of different substances are present, then we can say here that other than standard conditions, at standard conditions, so other than standard conditions, E cell, that means total cell. What is the total cell? If you take the two beakers, in that there is a salt bridge, this one is here is the voltmeter. So this total cell, this is, we call it as E cell. So this is the E cell. E cell is equals to, what will happen in E cell is equals to E, what happened in left side, that is oxidation, plus E of reduction, right side reduction. So left side oxidation is taking place, that means it is anode and this is cathode. This is anode and this is cathode. So anode, so E cell is equals to minus E red. If you take the E red plus E red, here it is anode and here it is cathode. So E cell is equals to E ox plus of minus E red, that is, it is anode and this is cathode. So if you see anode and cathode, right and left, if you take, every time we are taking the right is E cell is equals to E right minus E left, E right minus E left, that means this one, E right minus E left. This is the right one and this is the left one. This is where the both are here reduction potential, both are reduction potentials. So E cell is equals to E left minus E right, both are, this is the condition. So minus of E ox, this one, both are oxidation potentials. So here both are oxidation potential when both are different, both are other than standard conditions. At standard conditions, if you see, E naught cell is equals to E naught of red plus E naught of ox, or you can write as E naught of ox plus E naught of red, where the oxidation takes place, where the oxidation is takes place. Remember this one only, don't remember all the conditions. In different books given the different conditions, but remember this one: E cell is equals to E ox plus E red. Here E naught cell is equals to, just here the difference between this one and this one is the not. This is the standard conditions. This is the standard condition. So left, right, and don't confuse with that. So I can write it as E naught cell is equals to, this one is the oxidation, so E naught of ox plus minus E naught of oxidation. This is the anode and this is cathode. So here it is cathode. So and E ox here it is anode. This doesn't change here. Don't change the anode and cathode, just change the electrode potentials. So here E naught cell is equals to, if I write the E naught of minus E naught of red plus E naught of red, this is anode and this is cathode. So this is the anode and this is cathode. So both are in, this is left side. So if you take the beakers, two beakers and immersed a salt bridge, this is left, this is right, and this is, here it is battery. So this is left, right, here left, this is left, this is right, this is right. So here what is happening, here is oxidation, that means it is anode. So we can write as E ox, E naught ox, and here it is reduction, that is cathode, and it is a E naught of red. So E naught of red, and if you see simply you can remember oxidation means E naught of, what is happening here, metal is going to be Mn plus, and E naught of metal ions will going to be metals. So this is the representation if you see. So this is left and right, you can change according to given values. It is given oxidation or reduction. So this is simply we are taking here important points. Note that points, these points are very important in this electrochemical cells. So by taking two electrodes, to connect to construct a galvanic cell. What is that galvanic cells? You are taking two beakers and salt bridge. There is anode, cathode, everything you are taking. So this is a galvanic cell. Two beakers you are taking. Left side is the anode, A, B, C. Don't forget this one, A, B, and this is C. So galvanic cell, anode and cathode. Here the center is the bridge. So construct a galvanic cell with positive EMF, an electrode, positive EMF of an electrode with high reduction potentials, high reduction potentials are low oxidation potentials. These points are very important. Potential is taken as cathode, and an electrode with low reduction potentials, low reduction potential or high oxidation potential is taken as anode. Next, another point is an electrode with high reduction potential high reduction potential acts as strong oxidizing agent. Electrode with high reduction potential is acts as a strong oxidizing agent. That means a reduction potential is there. High reduction potential is taking as cathode. Cathode means reduction is taking place. So cathode, here it is a cathode. Cathode means what will happen? Metal going to be metal. So here taking the electrons, if I have another atom here, from this it is taking the electrons. So an electrons it is taking, that means it is going to be oxidation. So it is a strong oxidizing agent. So this is works as a strong oxidizing agent. Next it is with increase of reduction potential, oxidizing power increases with the increase of reduction potential, increase of reduction potential, oxidizing power increases, power increases oxidizing power increases. An electrode with low reduction potential act as strong. An electrode with low reduction potential acts as strong reducing agent. That means it is undergoing the oxidation. This is anode. So with a decrease of reduction potential, reducing power. So this is reverse to that. With the decrease of reduction potential, reducing power increases. So here we will see what are the these points. So first is an electrode with the high reduction potential act as strong oxidizing agent. That means it pulls electrons from other atom or ions or molecules. From atoms or ions or molecules, it pulls the electrons. That means it acts as a strong oxidizing agent. Means this atom or ion undergoes oxidation. This is a strong oxidizing agent. Next, this point is with the increase of reduction potential, oxidizing power increases. That means if I am increasing the reduction potential,